When Rust developers think of us C++ folks, they picture a cursed bloodline. Generational trauma passed down from malloc to free. To them, every line of C++ we write is like playing Russian roulette, except all 6 chambers are loaded with undefined behavior. They look at us like we're hopeless, like we're one dangling pointer away from therapy. But you know what? We don't need a compiler nanny. No borrow checker, no lifetimes, no ownership models, no black magic. Not even Valgrind is required. Just raw pointers, raw determination, and a bit of questionable sanity. So, in this video, I'm going to show you how to hunt down memory leaks like you were born with a pointer in one hand and a debugger in the other. If that sounds unreasonably dangerous and incredibly fun, smash that subscribe button and let's dive into the deep end of the heat. Okay, before we start, I have to remind you, in this video, we are tackling a specific kind of memory problems in C++, and this is going to work only on Microsoft Windows and Microsoft Visual Studio. There are various tools for dealing with memory problems on other platforms, for example, like Valgrind or address sanitizers or static analyzers. Those are like for a different topic. If there's demand for it, I could even create videos for those. But in this video, as I said, we are just focusing on a specific kind of basically memory issues. So I also write a blog post, which basically I'm going to share with you. You can find the link in the description of the video. In this blog post, there are explanations provided in detail for everything we are going to see in this video, and also the source code, which we are going to use to demonstrate basically the issue and the solution, are all provided inside this blog post. So let's first start with demonstrating the issue using a simple C++ memory leak. For this, we have to basically go to Visual Studio, and I have Visual Studio 2022, but you have if you have an older version like 2019 or 2017, it's gonna be the same. And for this, I'm going to create a new project, and I'm going to type here C++. If you cannot find the console application, because I already did create a console application, so that's why it's going to show it here. I can even pin it. But if you don't find it, basically here in the recent project templates, you are going to create a console application here, which is C++ for Windows and console. Let's go to the next page. Here, I'm going to give it a name inside, for example, drive D, the dev folder. I'm going to name the project name, let's say leak. Then I'm going to create a new project. So here's like the Hello World minimal C++ program. It is written by Visual Studio for us. Also some comments here, which basically tells us how we can start this project. Here, please note the solution that I'm going to demonstrate is going to work only in debug builds. So that's why it's important to put this on debug, basically the build tag. So here I'm going to run the program, and it always opens in my first monitor, so I always have to drag it here. Then here you see the hello world, and after that it just waits for me to basically press any key to close the window. Now, I'm not going to demonstrate the whole code I've written, but we are going to copy this. Probably it's easier for me to copy it from the source of the blog post here, but you can of course copy it from the blog post itself. And then I'm going to Visual Studio, going to replace everything here. So basically this program is a simple program. It's going to generate a password. For example, every time you call this function, it's going to generate a password for you. And inside the main folder, basically function, we are going to first basically have an endless while loop, and inside this while loop we are going to call this generate password function to always generate passwords, like with an interval. For example, here I put 1 millisecond. Every 1 millisecond I'm going to generate one password with this length, which is 1 megabyte. Basically the length of the password is 1 megabyte. I'm doing this on purpose because I want to be able to see the memory leak, basically demonstrated to you, to see it in a way that is observable. But anyway, in the while loop, we endlessly generate passwords and we leak the memory, and then we sleep for an interval, like, as I said, 1 millisecond, unless we press a key, the enter key, to interrupt the process. Let's see it in action. I'm going to run the program. It says there is an error. Why? Okay. Okay, because I didn't copy the full program, so I had to have my closing bracket here to run the program. Yeah, now it is running, and as you can see here, it constantly generates password, and here you see inside the Visual Studio Studio's diagnostic tools, we see the memory is constantly leaking. Like on every iteration, we are leaking around 1 megabyte of memory, and this could run faster, but because the output is slow, that's why it's almost around 1 second or maybe twice per second we are leaking memory. But as you can see, the memory is growing and it's going to continue, but of course because I have plenty of RAM, it's going to continue for a while before the operating system going to kill the application. But yeah, this is like a memory leak because we just allocate memory. We forget to release the memory. Okay, now we don't know basically where our application is leaking. The next thing I want to basically say is when you press the enter key, the application is going to stop, and then one more time if you press any key, it's going to go back to Visual Studio. But anyways, now we don't know for sure, but of course it's an easy program. You can probably spot it immediately. But let's imagine this is a more complex program. We don't have any idea where memory is leaking, and we want to track it down with ease. So for this, there's a second code. If you go to the blog post here, basically it uses something called CRT dump memory leak, which is something from Visual Studio. I've used this to track down the memory leak issue. For this, you have to modify the code a bit, but the first modification I want to make is, first let's reduce the amount of memory, because I want to reduce the amount of output. I don't want to just output a big chunk of text, but yeah, you saw the memory leak in action. Also, I'm going to increase the time to 1 second or 1000 milliseconds, which is equal to 1 second. Let's run the program again. It's still leaking, but this time it runs like the window runs slower, so we can spot what is happening here because we are demonstrating it. But here you see the memory, like it's going to increase really slowly, like it's not noticeable, the leak, but it's there, you saw it. But yeah, we did reduce it for the sake of simplicity. So here the memory is leaking like every time 64 bytes, and then like in every 1 second it's going to do that. But anyway, I'm going to end the program by pressing enter, and then let's go back here. Then there are 3 sections from this program you can copy over. Don't worry, we are going to explain what's going to happen. But for now, I'm going to copy this part and just put it here at the beginning of the file. And then the next part we have to copy is at the beginning of the main function here. I'm going to copy this, as you can see here. And also at the end, just before we return from the function, I'm going to copy another portion of the code. So that's it. That's all we need to track down memory. But I can comment this first. Because I don't want to basically show something. I had to basically show you the output window before I added this code, but I forgot, of course, to do that. But anyway, let's run the program. It's running, and let's find the output window. I'm gonna make this a bit bigger for you to see. And the application, it is running, as you can see, and generates password. I'm going to press enter, and that's it. Let's again pin output window here, because I want you to be able to see it, and unpin the solution explorer. So nothing in the output window except the usual, like it just runs the program and some text that Visual Studio outputs. But let's uncomment this line of code, and let's uncomment this part and see what happens. Okay, I'm going to run the application. Again, I am leaking memory. And then at some point, I decide to stop the application by pressing enter, and then another key. And now the interesting part happens here. Basically, Visual Studio, using the code I added, was able to track down the memory leaks. Not only the memory leaks, but also it's going to show us the content. Like this was the password that was generated, but it's going to only, for example, in this case, it's going to only show 80 bytes, but probably less, just part of the leak, the part of the string that is leaking, the first part. But let's see for sure, because we did close the window. Maybe I should clear the output, again, run it for you to see what happens here. As you can see, there's still nothing in the output window when I press enter. And here, before I close this window, let's go to the beginning. This is the first password which is leaking. And here you see it. It's the same password. Let's make this bigger. I don't know if I can make this bigger. Unfortunately, it seems I can't. But here you can see FEN. Here also you see FEN. The second one that is leaking is NRT, which you can see here, NRT. And the third one that is leaking is 5I, I guess Y, J, F, whatever. And as you can see, it just shows us every bit of memory that is leaking, and not just where it leaks, which basically shows the line as well, for example, line 95, and also the allocation number, like it's allocation number 161. And if I even double click on this line inside the output window, it's going to show me where exactly the memory leaks, like where we allocate the memory, and where we've then we forgot to basically release the memory here. So it's pretty accurate. As you saw, this is like a really simple tool, and believe me, I've like tracked down memory in very, very complex applications, like with layers of code, like even like applications that communicate with each other using IPC, like they are in separate executables, and it works really great. So basically, using this tool, we managed to find the program. Even if your code is inside the library, you are still able to find it. But this is not the only thing. Like, as I said, like here, there's the allocation number, like allocation number 161, number 171, and so on and so forth. For example, 176, whatever. And also you see some other stuff. Probably these are because we are leaking a std string. We allocate a pointer on the heap. Of course, I'm not going to explain the difference between heap and stack. I assume you know the difference here. But probably there are some internal heap memory or something, which that also leaks, and it just shows that as well. But anyway, the relevant part for us was here to see what we basically generated here, just to see it. I wanted to prove to you that it's able even to show the content, what is basically leaking. But anyway, not only that, but we can also, using this function here, I'm going to explain this later, don't worry. But every time we can basically even track down the leak number, like for example, we say allocation number is 161. Or for example, let's go for 176. Like the first 2 times it's not gonna happen, but the 3rd time it's going to happen. Then let's run the program. And as you can see, the 3rd time it's going to crash with a breakpoint. So here, basically we get a breakpoint, and if we go to the call stack window here, you get the call stack as well. Like it just crashed here inside some Windows DLL, EU, CR based .dll, whatever. And we can basically navigate back the stack, but that's not our code. Let's go, for example, here. Then we can go back here. It's gonna crash here basically. And actually we can go all the way to line 95. We told Visual Studio, when you are going to basically do the allocation number 176, please crash with a breakpoint. So for us to be able to see it, to see where it's crashing. So again, that's also one other facility that you have. So you can even choose the allocation or the leak that happens with a number and crash there. So I'm going to comment that, but of course in every run you can just track one of these. If you put more of these here, it's not gonna work. But let's go to the explanation. We saw it in action. It's super easy to use, and the explanation is even simpler. I already wrote some explanation, like explain like I'm 5 years old. And then also I provided the technical explanation and a summary. So the first portion of the code that we added here at the beginning was this portion, which we defined inside the macro, and we wrapped it basically here. We say if, for example, memory, define memory leak tracker, and then if we have this, we can of course disable it. That's why we do a definition here. If I put 0 here, it's going to be disabled. Like you see here, it's going to be ignored. Even if I press enter, you see I don't see anything. Basically, that's a feature I want. I want to be able to disable it whenever I want. I want to be able to enable it. If you put 1 here, it's going to be enabled. If you put 0, it's going to be disabled. But anyway, basically I do a macro definition, and then based on that, there are some code here. Let's see what it does. Okay, in the explanation, in a simple explanation, I could say, imagine we're building a Lego house, and we sometimes forget to clean up bricks afterward. This could say, hey, let's turn on a Lego brick tracker. So we have now a Lego brick tracker that is able to track the Legos. It adds a magic camera, which is this header that we are going to include, that watches where we drop bricks. And when we use new to build something, which we allocate memory, it secretly adds who built it and where in the code. Like it keeps track of everything. It has a log. It's going to write who and where basically that thing happened. So if we forget to clean up, we'll know exactly who made the mess and where. It's really simple. It's really beautiful. So the technical explanation. As I said here, first we define this macro. This is for Visual Studio. What this macro does basically replaces call to malloc, calloc or calloc, realloc, and free with debug versions that track source file and line number. Then we include this header, which gives access to Microsoft Debug heap and leak checking functions, only available on Windows with MSVC in debug builds, of course. Then we define basically this line, define debug new. And here, basically what we do, this is a trick we do that replaces every usage of new. If you remember here, we allocated memory here with new. If you remember, it's going to basically uses that macro, what we defined in there, which we'll see in a bit here. Normal block, file, line. We will see what is that. Which basically replaces this with a debug version, which is called debug new. And then this one logs the file and line where we allocate, where the allocation happened. This makes it possible to pinpoint exactly where a leak originated from. For example, here, let's enable it. Again, we are going to run the code. Now here I'm going to press enter. And as you can see, we see the file, line, and also the block of the memory, which is basically leaking. And it enables it to keep track of the file, the line, and the block of memory we are allocating. So, okay, then in summary, debug new and CRT DBG map alloc basically tracks new malloc calls with file plus line information. So it was easy, as you see. And then the next part is at the beginning of the main function here. Basically, we also wrapped it inside this macro. Basically, if we make it 1, this code is going to be compiled. If we make it 0, it's not going to be compiled. So here, basically the simple language explanation, basically this part tells the camera, remember the secret camera from our Lego example? What to look for. It turns on its leak detector goggles, so it can see every piece of memory we forget to put away. And that basically line here, basically this CRT set break alloc 162 line, that's like saying when you see the Lego block number 162, pause everything. Okay, I want to look at that one under like a microscope. So see exactly what's going wrong. I want to look at it with more detail. So that's it. Basically, it's just going to, as you saw, put a breakpoint there. It's going to pause everything. So the technical explanation here, as you can see, let's make this a bit bigger. CRT set DBG flags sets runtime flags to enable memory leak tracking and automatic leak reporting at program exit. That's why we do it at the beginning of the program. Before we allocate anything, we are going to put it in there. But yeah, if you put it at the end of the file, basically it's going to miss all those allocations. If we here inside our program, like here, if we put it after this line, it's going to miss all those allocation. If, for example, we put it here, then yeah, basically it's going to enable the runtime flags to enable memory tracking and automatic leak reporting when the program exits. Then here we also, I guess it's this one. Yeah. This other flag that we are enabling tells the debug heap to keep track of memory allocations. The other one, which is this one, this is actually important, automatically calls the CRT dump memory leaks function when main exits, when the program basically stops. Of course, for example, here, if I forget to do this here, because I do it also manually, if I forget this because of this flag here, because of this one, or was it this one or this one? Because I forgot. Yeah, it's this one. Basically, because of this one, it's going, the dump still is going to happen. Look at this. It still happens. But if I remove this flag, let's remove it. It's not going to happen. It never dumps. Yeah, it tracks the memory leaks, but it's not going to dump anything to the output as we see here, unless of course I have to do it manually here before we exit from the main function. As you can see here, it's going to dump the memory leaks. So let's go back Then why do we do it like twice here? It was just for the sake of demonstration. I wanted to you to see it's possible to do this automatically by passing this flag or do it manually here. What's the advantage? Basically, when you do it manually, it's like, for example, you want to have control where exactly it's going to be dumped before all the statics or whatever other stuff that you have are going to be cleaned up automatically. So there's also this line, which we explained already. Line, for example, we said the allocation number, the block 162. Then here, where is it? Yeah, sets a breakpoint on the basically allocation 162 as counted internally by the CRT heap. Of course, per program, this is different. Like, for example, on your computer, it could be something else. Even on my own computer, when I was writing this article, it was 162. But you see, now when we run, it's actually 161. So this can always change. This is something the Visual Studio runtime, basically C++ runtime, is going to keep track of, and it's just generated on the fly. Anyway, when hit, Visual Studio will pause execution, so you can inspect the allocation causing issues. You can comment this line out unless you're trying to isolate a specific leak in a large program. As a summary, basically, CRT set DBG flag enables runtime heap tracking and leak reports. CRT set break alloc lets you break on a specific allocation number. And the last part, which we already explained to a bit, to an extent, is this part, which this is when you pass basically this one, you don't even need this. It's optional. But if you don't pass it, then it is mandatory, of course, if you want to see the dump of the memory leaks. So at the very end, we tell the camera, like the simple explanation, okay, show me everything we forgot to clean up. Like, show me the log that you have, you kept track of everything. That's basically what it does. It dumps out a report saying, hey, you left a break at line 42, for example, and another one at line 57, for example. So it just keeps track of everything. And the technical explanation is manually triggers a leak report right before program shutdowns. This is optional if you already enabled, of course, we explained this flag. The CRT will dump leaks automatically, but calling it manually gives you control over when the leak dump happens before global static destruction. So as a summary, this CRT dump memory leaks manually prints out leak information with pointer and the size. So this was it. As you can see, we didn't need to deal with a borrow checker. We didn't need to know about ownership, lifetimes, whatever. And there was not really a black magic here. This is something implemented by Visual Studio, and as you saw, it was super easy to use. Even in complex programs, it's as easy as this simple program that we wrote to use. And then, yeah, that's it. Basically, you can track memory leaks using this tool. As I've said, of course, there are other tools like Valgrind, for example, runs on Unix-like operating systems like Linux, FreeBSD, whatever. You could use, of course, it's not available for Windows, but there are other tools like static analyzers and some compilers, for example, like Clang GCC, they have address sanitizer. Address sanitizers, these are used basically to track all kind of memory issues and deal with those. So we are not basically hopeless. We can use these to deal with memory issues in C++, of course. And once you start using these tools, you will start gaining experience with all kind of memory issues. Of course, I'm not going to basically ignore the value of Rust. I use Rust at work and I use it for my personal projects, but also I wanted to to show you in C++ is also possible to track down memory issues. And a lot of people probably don't know about this, but yeah, that's one tool in this video. Let me know Basically, if you need more information about other tools, or if you want me to make other tutorials about those tools, reach out, and the links basically to my social media are in the channel's description. You can always find it there. And yeah, that's it. If you like to basically receive a notification when I release a new video like this one, hit that subscribe button, like, and put a comment for the algorithm. I really do appreciate it. I hope you've enjoyed this video.